Good evening. I'm Judy Barr, a board member of the Wellesley Conservation Land Trust, and welcome to the first of our three-part series, Flower Power, How Native Plants Can Save Our Bugs and Birds. What better to do on a rainy night than to learn about the flowers that will be coming up in May and the future flowers that you might be planting in your yard. In 2017, the Natural Resources Commission invited Doug Tallamy to give a presentation called Creating Living Landscapes to Restore Nature's Relationships. This was early in his rise to fame. He's been doing it for a number of years now, but it was early in his presentations. And I think we have one of the jewels that he has given, even though it was 2017. So we elected to use this as our kickoff presentation. So we will present his 60-minute talk, and then it will be followed by a question and answer series with Heather Rose Mattila, who's an associate professor at Wellesley College, and also to present or to answer questions related specifically to Wellesley will be Raina McManus, who's the chairperson of the Town of Wellesley's Natural Resources Commission. Remember, after this talk, which is really to lay the foundation of why our native plants can help us save our birds and bugs, there are two other presentations, two other sessions. One will be next Thursday, which will be, now you know why, how do you go about designing and planting a native plant garden? And then the following week will be, how do you then maintain that garden? How do you rethink your yard care and end up doing less and saving more? The next slide gives you an idea of the Pollinate Wellesley is a summer effort that is a combined partnership among three organizations: the Sustainable Wellesley, the Wellesley Natural Resources Commission, and the Wellesley Conservation Land Trust. This series is one of the first parts of it, but the whole Pollinate Wellesley effort will go throughout the summer. It will have numerous kinds of activities that will occur. In the next slide, you'll see who are the groups that have been involved. What are the groups that have been involved? I've already told you about the partnership. We got together, figured out what would be a good approach for these three lectures, and the who, what, and the continuation became the theme. This is also co-sponsored with the Wellesley Free Library. And the planning group that pulled this all together is B. Bezmalninovic, Katie Griffith, Raina McManus, Judy Barr, and Michael Toman. B and Raina are present members of the Wellesley Natural Resources Commission, and Katie was an immediate past one. Michael and I are on the Wellesley Conservation Land Trust, and all five of us have participated in activities of Sustainable Wellesley. I just on the next slide like to show you the Wellesley Conservation Land Trust and where we are in town. Remember, we're the nonprofit land trust. We're founded in 1958. We have 10 sanctuaries covering 45 plus acres. We're advocates for natural spaces. We're providing educational programs. But one of the things that we also realize in our locations is that we have a lot of invasives. So lately we've been organizing first cricket Vlas, if you remember, early in the January, gave us a webinar about invasive plants and how to identify 5 and remove them. We also have a Girl Scout who will be doing her gold project in Guernsey Sanctuary, which is down in the lower southwest corner of town, removing a lot of invasives that are crushing our native wildflower garden there. Clara Eichblum will be be doing this along with Bill Giesen, member of our board, as well as myself. We also have had some invasive renewals, especially the burning bushes with Bruce Meltzner and David Hoffman, who are new members of our board of directors. So we're starting to do a lot of invasive removal in our own sanctuaries. So what are some of the issues that led us to pollinate Wellesley and to do this whole session during the summer? Some of the issues, as you know, the overall decline of natural spaces, growth of development, deforestation. So you have large lawn surfaces that have replaced more natural looking ones, and large oaks in the developing tear down areas have been replaced, have been removed so that the bigger house footprint can be there. But that's really creating quite an issue with the lack of oaks, and Doug Tallamy will be talking about that. Oak is one of our keystone plants. It's a native plant, and that's really affecting us. We're using a lot of pesticides in our yards and in agriculture, and pesticides kill insects, and that's affecting our bees and butterflies and things which are so important for the food chain. And when these native plants disappear, it's then increased the natives and the imported ones. So we have lots and lots of burning bushes. And the results are that 2/3 of our wildlife has vanished since 1970, that's nationwide. In 2013, a monarch study was done, and as compared to 1976, only 3.6% of monarchs are still migrating out of Mexico. Huge decline. A study in 2019 affecting birds, 2.9 billion fewer birds were detected as compared to 1970, or a 29% decrease in North America. And in 2019, 40% of insects were declining and could die out in coming decades. Most threatened are the ones that we need to feed the soft protein for our birds, the moths, the butterflies, and to pollinate our plants, the bees and the dung beetles. So in our next slide, there's some of the things that have been being done already in Wellesley. And this goes back to 2002. We've started to prohibit toxic pesticides on town property. There has been a growing effort called Grow Green Wellesley, and these are websites that on the town webpage that you can find out about. We're creating green spaces in Wellesley on town-owned property, where we're planting natives and pollinator gardens and transitioning to a lighter hand in our yard care with less raking, less use of gasoline powered and more use of electric yard care equipment when that equipment is needed. So that all led us to the next thing is, let's involve not just town property, but let's get people involved in their lands and their lawns and create a town-wide effort to pollinate Wellesley. And as I said, we're starting with this Encore presentation from April 29th. In the next slide, you'll be introduced to Doug Tallamy. And his talk, May 13th, 2017, was part of a whole day seminar calling a forum on eco-friendly gardening and lawn care. You'll find Dr. Tallamy, who is a professor of entomology at the University of Delaware, entertaining, informative, and gives us a path forward, how we can restore native plants and why native plants are necessary, how we can create a pollinator corridor, and what he calls a homegrown national park. It's each of us took a part of our lawn and converted it to a native plant garden. Think of the impact a homegrown national park could be created. And so that has created a stimulus for the town of Wellesley to take action, and this summer's townwide Pollinate Wellesley events. And the next slide are two of his most important books that support his message to us all, bringing nature home, rather than having them just in national parks in pockets of our country. Create homegrown national parks, bring them home. And nature's best hope is through the native plants that can be planted within our own yard. So that's the background. The webinar will last approximately 60 minutes from his talk. It'll be followed by a question and answer session. You are all on mute, so put your questions, whether they are general or specifically for Wellesley, in the chat function, and they will then be answered by two wonderful people. One in the next slide will introduce you to Heather Rose Mattila, who is a doctorate in biologic sciences and the associate professor of biologic sciences at Wellesley College, and our own Raina McManus, chair of the Natural Resources Commission. The next slide will show you, again, a reminder, the next two parts of our series. So we are now going to transition into the Doug Tallamy series. And what I'd ask you to do, this has been recorded. It's recorded at the volume that, and it's a little bit light. If you could increase your own volume on your computer, increase down at the bottom right, you probably will have something that looks like a speaker. Increase the volume of the speaker and you can adjust it as we go along. So with that, let's return to the year 2017 and enjoy one of the best Doug Tallamy talks ever. Take it away, Dr. Tallamy.
We can talk about restoring nature's relationships. We can talk about creating living landscapes. We can talk about 50 Shades of Green. It all means the same thing. By the way, I'm pleased to see a big audience today. It reminds me of a trip I took 3 students to in Southern Ohio last summer. There's an event called Mothapalooza. Do you know Mothapalooza? But on the way to Mothapalooza, we had to stop at Columbus, Ohio. I had to talk to an Audubon group. And one of the students said, "Can I come to talk with you?" And I said, "Sure." So we get there, and there's a room full of people, and he said, "Is this a conference?" And I said, "No, it's just me." And he said, "These people are here just to see you?" Yeah, I always wonder about that too. Okay, everybody can hear me? Yes? Let's get started. What is that beautiful bird? That's the resplendent quetzal, that's right. It's an endangered species in the forests of Central America, and it's endangered for one primary reason: it has a very specialized diet. If you don't have fruits of the wild avocado tree, you don't have that beautiful bird. And we've cut down most of the wild avocado trees. But we want that bird in our future, so we figured out we can plant them. We can actually put them back. That's what these folks are doing right there. Now, those trees are small, but they grow pretty quickly. And they reach the age at which they produce those fruits in not too many years. And it's starting to look better for that beautiful bird. But that same conservation scenario is repeated time and again. If you want to save the jaguar, you have to have particular species of palm trees. Why palm trees? Because they make palm nuts. Palm nuts happen to be the favorite food of peccaries, which is the favorite food of jaguars. So we're talking about specialization in the natural world, particularly focused on food resources as being the rule. It is not the exception, and it always starts with plants. Now, a lot of people think you get all that specialization in the tropics because there's so much of it there. But we have a great deal of specialization up here in the temperate zone as well, and some of the most specialized relationships that have ever evolved occur right in our yards. This is one of them. That is a female bola spider. She's hanging from a river birch leaf in my yard, and it's obvious why she's called the bola spider. She doesn't spin a web. She just drops a single strand of silk, but one sticky glob of glue at the end there. Now, she doesn't swing around her head like a bull, but she does go fishing with it. She lowers it and raises it and lowers it real slowly. And the first time I watched her do that, I told her, "You're not going to catch anything." I could not imagine something flying into that little target and getting stuck by accident. And also, that's the way I used to fish, and I didn't catch anything. But about 15 seconds later, a moth flew in and got stuck, and she reeled it in and actually laid her eggs on it. And what I didn't know at the time is that it was not an accident. She was releasing the sex pheromone of that particular moth. So this guy's a male. He thought she was a female. She is, but the wrong species. And that's the end of him. And it turns out that every species of bola spider in the world mimics the sex pheromone of one species of moth. So you can have bola spiders in your yard if you have the plant that supports the larval development of the species of moth that your bola spider is mimicking the sex pheromone of. Highly specialized. Phlox nevaricator, very common spring ephemeral in our garden, spreads readily from seed, but only if it's pollinated. And if you look at the entrance to the corolla there, it's extremely narrow. I've watched native bees land on these plants, try to get their mouth parts in there, and they can't do it. So who's pollinating our phlox? Well, if you do watch them carefully, you'll see it's day-flying sphinx moths, so things like the hummingbird sphinx or the snowberry clearwing. They have very long tongues. They sink them deep into that corolla, and when they pull them out again, they're covered with pollen. Superb pollinators of these particular plants. So you can get your phlox pollinated, make lots of seed if you have adult snowberry clearwings. And you can have adult snowberry clearwings if you have larval snowberry clearwings. And you can have larval snowberry clearwings if you have coral honeysuckle, which is their host plant. That's the native honeysuckle. Now, even animals we don't think of as having specialized relationships with plants often do, at least at one part of their life history. And I'm going to use the Carolina chickadee as an example. You have black-capped chickadees up here doing exactly the same thing. And we always think of chickadees as seed eaters because they're one of the most common birds at our feeders all winter long, eating seeds. But when it comes time to reproduce, to make more chickadees, they're not seed eaters. They become caterpillar specialists. That's what they're feeding their young. And if they're in a rich environment, they're going to feed them exclusively on caterpillars. And it turns out that they're not alone. Most of the birds in North America rear their young on insects, and most of those insects are caterpillars. So let's ask the question, why caterpillars? Got other insects out there. What is special about caterpillars? Well, I've been thinking about it, and I thought it could be because they're beautiful. Got a lot of beautiful caterpillars like the Pandora sphinx, the Coletta silk moth, spiny rose caterpillar, curve-lined owlet, our common black swallowtail, very beautiful, the major Daytana, hieroglyphic moth. This is my favorite, the spun glass caterpillar. Could be because they have cool names. Like the green marvel, the once charred punky, confused woodgrain, the cynical ground cat, the neighbor, the Donald. I know what some of you are thinking. Not my caterpillar. Yeah. All right, I don't really think it's because they're pretty or have cool names. Thank you. Yes. There's some practical reasons. One of is that most of these caterpillars are soft. And that means you can stuff them down the throat of your baby without fear of injuring the esophagus of the baby. And that's, I think that's an important reason. Another one is that relative to many other insects, they're large. So a medium-sized caterpillar is the same biomass as 200 aphids. So if you're a bird, you want to catch 200 aphids or one caterpillar. They're very nutritious. They're high in protein, high in lipids and fats. And it turns out, we're just learning now that they are the best source of carotenoids for birds during the spring when they're breeding. Now later on in the season, birds get a lot of carotenoids from berries, but there aren't any berries early in the spring. All right, what's a carotenoid? That's a carotenoid. Why do we care about them? First of all, only plants make carotenoids. We vertebrates don't make them. But they are still very important in our diets. And that's why my wife Cindy tells me I have to eat my carrots to get my beta-carotene, my tomatoes to get my lycopene, my whatever that is to get my lutein. She makes sure I eat all that stuff. They're antioxidants. They run around our bodies and they protect our DNA from oxidative damage. They stimulate the immune system. So we're just generally healthier if we have access to carotenoids. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but she was right. Improve sperm vitality, who doesn't need that? Improve sexual attractiveness. Now we're talking about this male vermilion flycatcher who takes the pigments from carotenoids and puts them in his feathers. So the brighter red he is, the more ladies he attracts, and that redness at least partially comes from carotenoids. Okay, back to chickadees. They're not making their own carotenoids, and they're also not eating plants when they're feeding their young. So they have to get the carotenoids from something that does eat plants, and yes, that something is insects, but here's the key. Caterpillars have up to twice as many carotenoids as other types of insects, and 3 times as many as spiders. And birds eat a lot of spiders. So apparently, caterpillars are not optional parts of diets for birds. They're essential parts of diets. And that means if you're a reproducing bird and you're in a habitat that doesn't have enough caterpillars, you're not going to be able to reproduce. Having almost enough isn't good enough. Got to get those chicks to the point where they leave the nest and they're independent. So that becomes the next question. If we're talking about chickadees, how many caterpillars does it take to make a clutch of chickadees? And the answer is it takes a lot. And it was these birds that taught me that. I put a little chickadee box up in my yard, and I put it low so I could set my camera up and take pictures of what they were bringing back to the nest. That's when I learned they're bringing back caterpillars, but I also learned they're bringing them back very quickly. Both the male and the female are cooperating when they're foraging, so somebody's always out looking for a caterpillar, and they can bring one back to the nest once every 3 minutes. In one 27-minute period, they brought back 30 caterpillars. How do they do that? By bringing back more than one at a time. Sometimes a whole bunch. And they're doing this all day long, 6 a.m. to 8 p.m., so they're working very hard. Now the next question is, how many species of caterpillars do they bring back? Why is that important? Well, I was watching them. In 3 hours, they brought back 17 different species of caterpillars. Now, if you think about how they're foraging, a chickadee will forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. So everything they need for the caterpillars has to be in your yard if you want them breeding in your yard. And in 3 hours, this chickadee found 17 species of caterpillars in my yard. That's important. Because if I had 1 or 2 species of caterpillars, and it happened to be a bad year for those species, there wouldn't be nearly enough for the chickadees to reproduce. But if I have 17 species or 34 species or 134 species, and I'm counting them now, I actually have a lot more than that, there will always be some combination of species that in combination will be common enough so the birds will be able to reproduce. This is an example of diversity in the food web creating stability in the food web. You've heard diversity creates stability in ecosystems. This is a main way that it happens. Now the chickadees get to breed every year, regardless of the weather, if we have enough species of caterpillars in the yard. Well, there was a guy by the name of Brewer, way back in 1961, decided he would count all the caterpillars that chickadees bring back to the nest every day. And I don't know why he wanted to do that, but I'm glad he did. It was between 390 and 570 a day, depending on the number of chicks in the nest. And they rear their young in the nest for 16 days. Then the chicks fledge. Now, after they fledge, the adults continue to feed them caterpillars for another 30 days. But they're flying all around, so nobody counted them. So just to the point where the chicks left the nest, that's 6,000 to 9,000 caterpillars required to get them to the point of fledging. And chickadees are tiny birds, 1/3 of an ounce. That's 4 pennies worth of chickadee. What if I wanted to make a red-bellied woodpecker that's 8 times heavier? How many caterpillars does that take? And of course, I don't want just chickadees and red-bellied woodpeckers in my yard, in our neighborhoods. We want all the common birds. We certainly want our scarlet tanagers and our tufted titmice and blue jays and bluebirds and tree swallows and common yellowthroats and indigo bunnings and towhees and yellow warblers and wood thrushes and wrens and cardinals and hummingbirds. These are all birds we expect to be around, and they used to be around. But can you imagine the number of caterpillars required to keep breeding populations of those? Not just one pair. Breeding populations. It's a big number. Now you might be thinking, well, we don't need any insects for Mr. Hummingbird here because it eats sugar water. And it does eat sugar water, but 80 to 90% of a hummingbird's diet is insects and spiders. Then it goes for the sugar water. And that is true for 96% of the terrestrial birds in North America. That's a list of the bird families that are rearing their young directly or indirectly on insect protein. And when I say indirectly, I mean a lot of these guys are eating spiders as well, but the spiders needed insects to become spiders. And this is news to a lot of people. It's news to people who write landscape for birds books, because they will tell you how to put plants in your yard that make seeds and berries. And that's good. We want to make seeds and berries, but we also have to put the plants in our yard that make the insects, that make the birds so they can eat the seeds and berries. No insects, no baby birds. We'll just kind of struggle through these blinks here. All right, how do we do that? What types of landscapes are capable of producing the diversity and abundance of insects that we're talking about here? To answer that question, I've got to tell you about the most common type of specialized relationship that we have all over the planet, and that's the relationship between the insects that eat plants and the plants themselves. So we're not talking about pollinators here, not yet. We're talking about this polyphemus moth caterpillar and the oak leaf that it's eating. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction, so they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants. And that's why in just a week or so, you can look outside, it'll be green all over. And it's not because there are no insects out there that want to eat those plants. It's because most of those plants are so well protected chemically that the insects that are there can't eat them. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. It turns out that 90% of the insects that eat plants are what we call host plant specialists. And that means they picked one or two plant lineages that share a common cocktail of chemical defenses, and they've developed the adaptations required to circumvent those chemicals. The enzymes that enable them to detoxify those chemicals or store or excrete those compounds. Behavioral adaptations, life history adaptations that allow them to minimize their exposure to those compounds. But it takes a long period of exposure to those plant lineages for all these adaptations to fall into place. It does not happen overnight. Let's use the monarch as an example. I'll use this as an example because you know half the story about monarchs. They, of course, are specialists on milkweeds, and you know milkweeds are toxic plants. They produce cardiac glycosides. Those are compounds where if you go out and eat milkweeds, it'll stop your heart. That's why we don't eat them. It doesn't stop the monarch's heart because they've got those enzymes that are going to deal with those cardiac glycosides, and they actually store them in their blood and their wings so that they become distasteful. But milkweeds are called milkweeds because they've got sticky latex sap in them too. When we cut open the leaves, that white goo comes out and gets on our fingers. We usually wipe it off right away, but if you leave it on your finger and let it sit there for a minute or so, it's being exposed to air and it will gel. It becomes like chewing gum. Now imagine you're a monarch caterpillar and you're chewing through a milkweed leaf and all this stuff gets on your mandibles and then it hardens to chewing gum. You can't eat anymore. It's gummed up your mouth parts, and you would starve. So how do monarchs eat milkweeds without getting all the sticky goo all over their mouth parts? Well, you can watch them right in your yard. This is a caterpillar that will, the first thing it does is crawl up a leaf, go down to the bottom of the leaf, and start to eat. And if any milkweed sap starts to come out, because sometimes it doesn't, but if it does, they'll stop eating immediately, turn around and crawl 2/3 back up the leaf, and they start to snip through the midrib of that leaf. And what they're doing is blocking the canals that shunt that latex sap down to this end of the leaf. So after he cuts through the midrib, he turns around and goes back, and then he can eat the leaf without any milkweed sap. And that's how monarch larvae do that. Now the weight of the caterpillar often flags the leaf, and that's a convenient way to find monarchs. You can drive down the road and look for those flag leaves on milkweed patches, and you know there's some monarchs there. All right, so those are that's the upside of specialization. By developing specialized enzymes and behaviors, monarchs can eat a plant that's unavailable to most other insects. The downside of specialization is that now that's all monarchs can eat. So by developing all those specialized adaptations, they haven't developed the adaptations to get around the tannins that are in oaks, or the cucurbitaceans in cucurbits, or the nicotine in tobacco, or the cyanide in cherries, and on and on and on. And what that means is if we don't have milkweeds, we don't have monarchs. And that's, of course, exactly the problem we're in right now. We've never been very nice to milkweeds in our residential neighborhoods. We've always relied on other places to produce these plants. First of all, we have a marketing issue with native plants. We call them all weeds. So no wonder nobody plants them. If we called milkweeds Monarch's Delight or something, then it'd be okay, you could plant it. But we haven't done that very well. We used to rely on the edges of ag fields and had lots of weeds. They had all the flowering plants that our 4,000 species of native bees depended on. Mostly gone now. We've got a new agricultural ethic where we have Roundup Ready corn and soybean, where we keep it either bare soil, no weeds, or now it's mowed lawn on the edges of the crops, and it looks very nice, but it's been ecologically devastating to these things, and that's why the monarch has decreased 96% since 1976. We're trying to save it. We got Monarch Watch. Everybody is planting milkweeds now. There's still problems in Mexico. We hope we can save it. Lucky for the monarch that it's pretty, because if it were an ugly moth, nobody would care. We humans love beauty, and we want to save this. But there's nothing special about monarch specialization. All the other insects that are specialized out there need the same kind of help that the monarch gets. I don't want you to think that it's only butterflies and moths that are specialists. This is the elderberry beetle. It only eats elderberry. The dogbane beetle only eats dogbane. Sumac flea beetle only eats sumac. This is a Korean bug, a leaf-footed bug that only eats ash. So if the emerald ash borer takes out all of our ashes, this species will disappear. Dave Wagner, University of Connecticut's finished a paper where he's looking at the ash specialists. It's 95 species that depend on ash, and they will all disappear if we lose that plant. And that's the problem, the fact that so many of our insects are specialized on just a very few species of plants. If you take those plants out of the landscape, those insects disappear. The good news is that we are learning more and more about, through these specialized relationships, we're learning what comprises different food webs. So we're learning how to rebuild these food webs by putting the plants in our yards or in our corporate landscapes, wherever, that produce the insects that support other things. Let's use the white-eyed vireo as an example. I'm going to use that as an example because that's the nest that Cindy found in her yard a few years ago. Now, these birds knew that I needed to take pictures of the caterpillars they're bringing back to their young. So they built the nest nice and low so I could set up my camera again. What we're going to do is identify the caterpillars. We know a lot about what caterpillars eat. So if we identify the caterpillar, we know what plant it came from, then we'll know what plant is necessary to help feed the white-eyed vireo. This is the blinded sphinx moth. It's a specialist on black cherry. I have a lot of black cherry at home, making blinded sphinx moths and many other things, so the babies get to eat. That little guy's the chestnut caesura, and despite its common name, it's a specialist on native viburnums. Now, our yard was mowed for hay before we moved in. We know the plants that are there because we planted them. And the viburnum we put back is arrowwood, Viburnum dentatum. It's now making chestnut caesuras, and the babies get to eat again. This guy is the drab prominent, specialist on sycamore. Now, we did not plant sycamore at home, but about 13 years ago, there was a big wind, blew in some sycamore seeds. One landed in my cold frame and germinated. And I'm not very fast at weeding things out. It's now well over 40 feet tall. But it's making drab prominence, so the babies get to eat again. And on we go. There's the 8-spotted forester moth, a specialist on native grapes. We have lots of those. The lunate zale, that was the moth you saw in the leaves in the beginning. That's a specialist on black cherry. There's the spicebush swallowtail. There's its phony eye, which is supposed to scare the bird into thinking it's a tree snake. Didn't work this time. It's a specialist on spicebush and its close relative, sassafras. We have both of those. The tufted bird-dropping moth, another specialist on black cherry. So now black cherry is emerging as a really important component of this bird's food web. But these guys are hungry. They need a lot more than that. So let's put some black walnut into the landscape. If we do that, we get the walnut sphinx, the gray-edged bomaloca, the black blotched caesura, the bride, all specialists on black walnut. If we have native maples, we get Plagodes inchworms, the green striped maple worm, the maple bantam dagger moth, and many others, of course. Native elms give us the four-horned sphinx, the double-toothed prominent, the interrupted dagger moth, and again, many others. Remember, 90% of the insects we need to rebuild this food web are not going to be there if we don't put the plants in our yards that make those insects. So if we want the mustard sallow, we need witch hazel. If we want the hackberry emperor, we need hackberry. If we want Cuculio asteroides, we need native asters. The Arcigera flower moth and the brown-hooded owlet need goldenrod. Hog sphinx, Pandora sphinx, Abbott sphinx all need Virginia creeper. The redbud leaf roller needs redbud. The gray furculum needs native willows. The turbulent phosphella needs greenbrier. And the orange tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red humped oakworm, the orange humped oakworm, the pink striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the white-blotched heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and many, many more won't be there if you don't have oaks, because oaks are the most important plant you can put in your landscape. By the way, you know where I took all those pictures? Yes, my yard. Many people say your backyard. And then I get to say, no, my front yard. I don't like the term backyard habitat because it implies everything we're talking about is so ugly we have to hide it in the backyard. You do not. You can have your oak tree in the front yard. It'll be okay. Why do we want all these caterpillars, all these insects? Well, we talked about the birds. They need them, and yes, we like our birds. But it turns out that insects are critical components of almost every terrestrial food web that is out there. Spiders, remember spiders eat insects? Yes, all spiders eat insects, or they eat other spiders that ate insects. Now, a lot of people don't like spiders. They say, well, I don't want them, but look who does. It is the second most important component of bird food webs. If you lost your spiders, you're really hammering the birds. And of course, they're predators of the insects that many people don't like as well. Then we've got insect predators eating the insect herbivores. If we lose these herbivores, we lose these predators, and they all are part of food webs. If we lost our insects, we would lose our frogs, our toads, all of the amphibians, because they all eat insects. So do our lizards, so do our bats, so do our rodents. We always think of rodents as seed eaters, and they do eat seeds when they can't find enough insects. And the reason they're doing that is that insects are just really good food. Pound for pound, there's twice as much protein in insect meat as there is in beef. And insects have organs in their abdomen called fat bodies that are loaded with lipids, high energy compounds that allow these guys to grow quickly, reproduce quickly. And if you're a mouse, if you're a rodent, that's what you want to do because there's so many things that want to eat you. Same reason that larger animals are eating insects. They're just really good food. The skunk is digging up your yard to get the grubs that are in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. Even things we don't think of as insectivores eat a lot of insects, like our friend the red fox here. 25% of a red fox's diet is insects, a full quarter. 23% of a black bear's diet is insects. So it doesn't matter how big you are, you need insects. Even if you don't eat insects, you need insects. This is a sharp-shinned hawk. It's a bird predator. And you might think, well, I can get rid of all the insects in my neighborhood and still have sharp-shinned hawks. But think about it. The birds this guy needs to eat needed insects to become birds. So he needs them indirectly. So does the garter snake. It's not eating insects directly, but it's eating the frogs and toads that ate the insects. The important message here is that a world without insects is a world without biological diversity. And E.O. Wilson told us decades ago that a world without biological diversity is a world without humans. And that's why this is an important message for everybody. Whether you like the life around you or hate it, you absolutely need it. It's the biological diversity in our world that is running the ecosystems that keep us, we humans, alive. Very important. Well, what's happening to all these insectivores, all these things that depend on insects as the number of insects decline? They're starting to measure this in Europe. We haven't measured it very well at all here. One thing we do measure, though, is birds. We like birds. We have something called the State of the Birds Report. It comes out, I believe it comes out every 2 years. 2 years ago, 2014, they said 230 species of North American birds at risk of extinction. 230 species. Just 2 years later, that's now 426 species. Not headed in the right direction. 1.5 billion fewer breeding birds today than just 40 years ago. 46 species of birds have lost half of their population recently, last 10 years or something. Our birds are in trouble. And again, this is an important message to us. Our birds are in trouble because the ecosystems supporting them are not happy. And those are the same ecosystems that support us. The birds are the canaries in our coal mine. We need to listen to this. All right, our ecosystems aren't happy. What's wrong? We've got parks, we've got preserves, And part of their job is to maintain the species that we need on this planet. That's not working. So let's look at what the problem is. There are actually a couple of problems. We're just going to look at the biggest one, and that is they're too small. The biggest problem is that they're too small. When you take a large area like this and you shrink it down to a little habitat fragment, and that's an exaggeration, but if I had flown here, and if I flew home, I'd look out the window, and that's what I see, all these little habitat fragments that are isolated from each other. You're taking large populations and shrinking them down to small populations, and that is the problem, because small populations are highly vulnerable to local extinction. Why? Because all populations fluctuate. Good times they go up, bad times they go down. If you're a large population, lots of individuals, even in your down cycle, you've got enough individuals that you can increase quickly when times get better. But if you're a tiny population, often in these random fluctuations, you hit zero. You blink out of your little habitat fragment, and then you're gone. Unless you recolonize it, you're permanently gone. And picture a box turtle crossing 95. It's not going to happen. And that's the problem. Studies all over the world are showing that our natural areas are too small to maintain the nature that we need them to maintain. I should say sustain. Sustainable doesn't mean for 5 years. It means forever. And they're draining species at a rapid rate. Unfortunately, that means our largest national parks as well. And some of these studies are quite old, 100 years in length. Okay, I've learned that we have a limited ability to absorb bad news. We have a little bad news cup, and when it's filled, we don't take in anymore. And I know your bad news cup is almost filled, so just a few more drops. We've taken nature, we've fractured it, we've fragmented it and isolated it, but we've also introduced organisms from someplace else. Let's just talk about the plants. We'll call them invasive species. 3,300 species of plants are considered invasive these days. They're plants from other continents that are aggressively displacing the native plant communities that we have around us. That is a picture of White Clay Creek State Park. So this is one of the parks that I'm talking about here. I drive by it on the way to work in University of Delaware. There's a period in the spring where our plants, and it happens for you too, the plants from Asia leaf out before the plants from North America. And that is a perfect time to look at your natural areas and see what the alien plant load is. That's the alien plant in White Clay Creek State Park. Every bit of green you see there does not belong there. And it's all of our favorites. It's multiflora rose and oriental bittersweet and Japanese honeysuckle and bush honeysuckle and miscanthus and burning bush and privet and barberry and ailanthus and Norway maple and on and on and on. And every one of them is an escapee from our gardens. So we don't have to wonder where these guys have come from. But now more than a third of the vegetation in this park is from Asia, which means those plants have not been here long enough to develop the specialized relationships that drive the food webs that I'm talking about. Well, what happens to those food webs? What happens to all the things that depend on our native plant communities when we replace native plants with non-native plants? So it either can be through a plant invasion, or it could be in our ornamental plantings, where we put in our crepe myrtles and our calorie pears, not thinking about what those plants need to do. That's what we've been measuring in my lab for the last 12 years, I guess. We have a lot of data, a lot of published papers. You can go to the literature, you can read them. I know you're not going to. But one thing that makes it easy is we always get the same answer. So I thought I would just share with you a little experiment that you can do on your own to test whether anything I'm telling you is real or not. I call this my 12 by 12 experiment. That's what 12 feet by 12 feet looks like if you stake it out in your yard. Now you get to determine how much life is going to exist in that space by determining how many plants you put in that space and what types of plants you put in that space. You can keep it as lawn. You can get on your hands and knees on Wednesday and count all the biodiversity in that 12 by 12 section. It won't take you long. And then, of course, on Saturday when you mow it, you kill it all. Or let's put a tree in there. Let's put a white oak in there. Now, here's a white oak that I planted from an acorn. 14 years before I took that picture. That proves two things. First of all, acorn free. I did not have to buy a 4-inch caliber oak for $3,000 and then have a 50% chance that it would die because the roots are so pruned. And then once I put it in the ground, it sits there for 10 years trying to rebuild the roots without growing. It also proves that oaks grow. I hear landscapers tell you, don't plant an oak, you won't live long enough to enjoy it. I'm enjoying it. It doesn't have to be 300 years old for you to enjoy your oak. Okay, 12 by 12 experiment. Let's walk. That fills the 12 by 12 section very nicely. Let's walk around at head height and just count the caterpillars on those leaves. We're not climbing the tree, no ladders or anything. We're just going to count the caterpillars in here. And we're going to do it on July 25th of 2014. We're going to find 410 caterpillars from 19 different species. Then I'm going to stand back and take that picture right after I finish counting the caterpillars so I can ask you, how many of those caterpillars do you see? How much caterpillar damage do you see? That's what we worry about. But this is the distance at which we view our trees. But if I knocked on your door and said, you've got 410 caterpillars on your oak tree, get the spray can, call the man, save the tree. You don't have to save the tree. This is what oaks do. This is what trees do. They pass on part of their energy to these caterpillars, which are soon going to be in the belly of a bird. You have living things in your yard because your tree is willing to do that. I met a woman in New Orleans a couple months ago, Tammany Baumgarten, and she suggests we all practice the 10-step program. Take 10 steps back from your trees, and all of your insect problems disappear. And I think that's good advice. Okay, now let's go to a black cherry. And we'll talk about this at the end. I'm not talking about gypsy moth here. I'm not talking about introduced insects. That's a different story. Here's a black cherry, 12 by 12. Count the caterpillars, 239 caterpillars from 14 different species. Now let's go to my neighbor's house. Now my neighbor moved in same month that we did. I have 10 acres, he's got 10 acres. He had different plant choices. He really liked calorie pear, which is also, you might know it as Bradford pear. I don't know if you use that a lot up here, but we certainly use it a lot down south. So he planted 32 of them. And this is a species from Asia, highly invasive, but he likes his Bradford pears. So the first thing we have to do is decide which pear we're gonna count. So we'll count this one. Actually, the first thing we have to do is make sure he's not home. We'll walk around 12 by 12, count the caterpillar. I did find one geometrid, one caterpillar from one species. Then I went to his burning bush, carved out a 12 by 12 section. By the way, I spend most of my time pulling these plants out of my yard. I don't want them. 12 by 12, 4 caterpillars, 1 species, 4 little leaf skeletonizers that are too small to be part of a local food web. Okay, now in science you replicate. You either design an experiment where it's replicated within it, or you repeat it over and over again to see whether the pattern that is there is real, whether it's going to be consistent. So let's do it the next day, same species but different plants. And we get different numbers but the same pattern. 233 on the white oak, 53 in the black cherry, 2 in the burning bush, 1 on the calorie pear. And we can do this 10,000 times. That is the pattern you're going to find. We have some very powerful native plants that are producing almost all the food that's out there, and these plants from Asia or South America or Europe can't do it because they haven't been here long enough to develop those specialized relationships. It doesn't make them evil plants. They're just not part of our ecosystems. They don't get to play the games that are necessary to play. Rick Dark and I gave a talk in Williamsburg, Virginia, not this spring, but the spring before that. And after the talk, we drove across the Bay Bridge and up the eastern shore of Virginia and Maryland, and we got to the Sunset Beach Inn and Grill, and there are all the calorie pears in full bloom. And that is why people plant them. Nice bloom in the spring. They've got nice fall color. The real reason is they're the cheapest tree you can get on the market, and they're still pushed out there. Now, once you get the ice storm, down they come. They don't live very long. But that was apparently the only choice of the Sunset Beach Inn and Grill. So we kept driving right up, whatever that is, 301, I guess, right past the Sunset Beach Inn and Grill, and we came to this property. Now, I found out this is owned by a land conservancy. They're interested in preserving this land, and look, it is thoroughly invaded with the offspring from those plants. That's what a plant invasion looks like. So now it is loaded with a plant making 1 caterpillar, not nearly enough to feed our chickadees or anything else. This acreage has been biologically castrated. This plant is biological pollution, and that is that's the horticultural ethical dilemma of our times. Most people would argue the Sunset Beach Inn and Grill has the right to plant any plant it wants on its property. But does it have the right to biologically pollute all the land around it? I can drive from New York City to Richmond, Virginia at the right time in the spring, and it's white all the way down from calorie pear that nobody planted. They were escapees from our gardens. So there are real consequences to this property rights idea that we have the right to do anything. If those were smallpox spores, we would agree it's not a good idea to put them there. What about pollinators? Let's talk a little bit about pollinators. What do invasive species mean for pollinators? So here's Japanese knotweed. You got some of that up here. I've seen it. We have 4,000 species of native bees. We have one species of honeybee, which is pollinating a lot of our crops. Honeybees will go to the flowers of Japanese knotweed because it's not a non-native plant for them. But out of that 4,000 species of native bees, we've got a number of generalists, and you see them, but we have a lot of specialists. We're learning what those specialists need. That means they go to single genera of plants. So how many specialists does Japanese knotweed support if it takes over an area like this? 0 specialists. If it wipes out the goldenrod that used to be there, goldenrod supports 11 species of specialists up here in New England. Willows support 8 more species of specialists, and asters support 7 more species. So just losing those 3 genera of plants to your Japanese knotweed invasion, you've lost 26 species of native bees. And that's the consequences of shifting these plants out to non-natives. Okay, if we're not going to plant calorie pear, what are we going to plant? Well, we make lists in my lab. This is the first list we made. We made it for a particular reason, but it turned out to be valuable for another reason. This is a ranked list of the woody plant genera in North America, in the mid-Atlantic states. And the numbers after each plant genus are the number of species of caterpillars recorded in the literature as using those plants as host plants. So memorize that. I said this became interesting to a lot of people because if you focus on this part of the list, you're learning the plants that are going to support most of the life in your yard. So I'd go to Wisconsin and people say, where's our list for Wisconsin? This is mid-Atlantic. It doesn't help Wisconsin. Florida, where's our list? California, where's our list? Well, it took my technician, Kimberly Shrupshire, 2 years to make that list. 4,000 references, a lot of work. So I said, if you support my technician, she will make you a list. Well, the Forest Service said, we'll support Kimberly for 1 year, but we want a list for every state in the union, and we want a list for every county in every state. Can she do that? Really hard for me to get support for old Kimberly, so I said, of course she can do that. Turns out she couldn't do it. It took her 1.5 years. She got much faster at it. It is now done. It's launched on the National Wildlife Federation website called Native Plant Finder. That's the URL. This is the beta version. So it's being tested. The first thing we learned is that that web guy that we hired to do this is a huge data set. Well, he decided he would only put in half the plants. So we're fixing that, but if you notice clear mistakes in this, let us know. But it's going to be very, very functional, and it is up and running at this point. The idea is that you put in your zip code, and the ranked list of both woody and herbaceous plants will come up for your county, and that will help you zero in on the best plants to use to support the most life right where you live. In making this list, I noticed a really, really powerful pattern. I should have noticed it before, but it really hit me between the eyes this time. When you go around the country and you look at the plants that are making most of the food, it turns out it's just a few of them, So I started calling those really powerful plants foraging hubs. I borrowed a term from the people that study birds foraging on trees that make fruit in the tropics. I have learned that you don't like foraging hubs. But here's my reasoning. I was sitting on a Delta plane once, not going anywhere. So I was looking at the Delta magazine, and those are Delta hubs. And I said, that's what I'm talking about here. Let's make them foraging hubs. There you go. So all the lines going into this oak tree here, each line could be a bird, could be a species of bird, could be a lizard. It's going into that oak tree to get something to eat because there's a lot of food there. Now the black dots, all these other black dots, are plants in that landscape too. And there are lines going to those plants, but not very many, because they're not making very much food. So imagine what would happen if we took these powerhouses, these foraging hubs, out of the landscape. You'd still have dozens of species of plants in your landscape, but it would be a failed food web. You wouldn't have nearly enough food. And that's the important message here. These guys are absolutely essential to a successful food web. And it turns out that 5% of your local plant genera are producing 75% of the food. So you could turn that on its head. You could build a landscape using 95% of the available plant genera, but if it didn't include those core genera, those hosts with the most, those keystone genera, whatever you want to call them, you're going to have a failed food web. You'll only be making 25% of the food that you could make. And it turns out that these foraging hubs, this pattern exists everywhere. These are the bioregions of North America, and it doesn't matter what bioregion you're in, you get the same pattern. It doesn't matter whether you're in the north or the south, you get the same pattern. So that's good, because it means no matter where we are, all we have to do is learn the foraging hubs. We know these are essential in our landscapes. Then we can add the other plants to diversify. It will increase the number of things you have in your yard, but not dramatically. So around here, oaks, number one, 557 species of caterpillars in the mid-Atlantic states, 557 species of bird food. Look at it that way. Now, what does that mean? Let's compare that to ginkgo. Ginkgo biloba from Asia, very common street tree. We use it all the time. Our lists say that there are 4 species of caterpillar on ginkgo. I think they're all mistakes. I know that several of them are mistakes. And I have asked people, for years now, if you see a caterpillar eating a ginkgo, take a picture of it and send it to me. I have no pictures at this point. So I think that's really a 0. But whether it's 4 or a 0, compare that to 557 versus that small number. Which would you plant if you're trying to build a food web in your yard? Number 2 on our list are prunus, the things like black cherry and pin cherry and American plum, Chickasaw plum, beach plum. Very powerful plant, 456 species of caterpillars on native prunus. Let's compare that to zelkova, another street tree from Asia. 0 on zelkova, and we're using that a lot in the mid-Atlantic states anyway. That's what it looks like. I guess we plant it because it reminds us of the elms we lost to Dutch elm disease. And if you're looking for a plant that is going to be perfect all the time, won't interact with anything, zelkova is for you. But I suggest you put a plastic one in or a silk one. Then you don't have to water it, and it'll be just as alive as the living one. Okay, this is Pieris japonica. Used to be the most common foundation plant we had in North America. We have native Pieris. But look, native Pieris are not very powerful genera, even though it's native. Only 2 species supported by Pieris japonica. I don't think Pieris japonica, or by Pieris. I don't think Pieris japonica actually supports anything. Could be a native viburnum that supports 103 species. So there are real consequences to our plant choices when we landscape. Think of the plants in your landscape as if they were bird feeders. There you go. Now you get to decide how well you're going to feed the birds. You can feed them a lot, or you can feed them just a little bit. This is what the landscapes around me look like. Giant lawns with just a few plants in them. You can put food in your bird feeders. The birds are not eating the feeders. They're eating the insects that are on those plants, or you can keep them empty. There's the ginkgo back there. It's a big tree, but it's not making any food. And when we decide to landscape with these non-native plants, the plants that are not the foraging hubs, we're not fooling the birds that are trying to breed in our yards. Here's a little bit of data from my PhD student, Desiree Narango, who's working in the suburbs of Washington, D.C., on Carolina chickadees. She's following 92 pairs of chickadees and looking at their breeding success depending on the landscape in which they're breeding. And she can manipulate that, because if you put up a nest box, the chickadees will try to use it because nest holes are so limiting. That's where the nest box was. And this is the foraging territory that includes 95% of all the foraging that these birds did. And the blue areas are the plants on which they did that 95% of the foraging. So let's look at what the species are. They're all the native trees in this landscape. So basswood and sweet gum, American elm was the big one here, black cherry, 2 species of oaks. Let's also look at the plants the birds do not go to. And they're all the plants from Asia: Japanese maples, silk tree, our friend the ginkgo, black poplar, crepe myrtles, Leyland cypress. And it's very easy to picture a landscape where those are the dominant plants, because those are the ones we use ornamentally all the time. And when that happens, this happens. This is a failed nest. After Des took the 3 dead chicks out of the nest, she noticed a bunch of sunflower seeds in the bottom of the nest. And remember, chickadees can't feed their babies sunflowers. The babies can't eat seeds. So what she thinks happened is that these parents ran out of caterpillars. But somebody had a bird feeder up, so they did try to feed the babies these sunflower seeds, and of course they couldn't eat them, so they starved to death. That's it. They blinked out. So there are consequences to the way we landscape. Here's some more data from her study. I don't want to overwhelm you here, but if you compare an 80% non-native landscape, and that seems like a stretch, but we've measured the landscapes around where I live, 80% of the plants are from China. With 100% native landscape, and this is suburbia, these are real numbers. If you start with 100 females, you end up with 200 fledglings in the all-native habitat. And if you start with 80% non-native, you end up with 82 fledglings. So 2.5 times fewer fledglings. Why is that important? This 200 fledglings is replacement rate. If you start out with 100 females, you need 100 males, so you've replaced the population. It's a steady population. This is a declining population because they're not replacing them. So when we landscape in the typical ornamental way we do, we're killing our birds. She's also looking at the migrants that are using those birds, those landscapes as stopover points. Our migrants, and 51 species she's recorded so far in her suburban plots. Our migrants do not fly around cities. They go right through them. Impossible to fly around cities these days. And they fly all night. They come down during the day to rest, but most important, to eat. They've got to gas up again. They're out of gas after their night of flying. If they have a tailwind, they can make 300 miles in a single night, so they have to eat. And if they come down in the land of ginkgo, there's nothing to eat. And then that's the end of the migration. So we don't have to wonder why we got 426 species of birds at risk of extinction. We're doing a lot of things to our birds, but starving them is something most people haven't thought about. So you don't have to save biodiversity for a living, but I do encourage you to think about saving it where you live, because we humans are pretty much everywhere. We cannot rely on nature anymore. We've got to do it right at home. We've moved plants and animals all over the world, creating what Richard Hobbs calls novel ecosystems. And a novel ecosystem is simply one in which the organisms are just meeting each other for the first time in evolutionary history. And what that means is they have not had the time to develop all those specialized relationships. What that means is, in these novel ecosystems, we're losing species. Anything that depends on a specialized relationship is gone. So if we're losing all these species, let's ask the question, how many species do we humans need? Let's be selfish about it. I'm going to argue that we need all of them. We need all of them because, again, it is these species that are running our ecosystems. Let's not talk about ecosystem services. Let's talk about biodiversity services. It's the plants and animals in our ecosystems that are keeping us alive. And of course, the Millennium Ecosystem Assessment completed in 2005, 1,300 scientists from around the world measuring the Earth's ability to support us. Their unhappy conclusion is that we've already degraded the Earth's ability to produce these ecosystem services by 60%. That's the ocean. That's not a recycling plant. That's the same as taking planet Earth and shrinking it by 60%. At the same time, we're increasing our population, increasing our economic growth, taking more and more resources. Anybody can tell that that is not a sustainable relationship. We've turned the world into Gone with the Wind here because it's all been about aesthetics. This landscape is not designed to produce ecosystem services, but it could be, and if it was, we could grow the planet again. The reason we've shrunken the planet's ability to support us is because we've taken away the thing that does it, and that's plants. That's plants. Put the plants back. Let's reevaluate what we're asking our landscapes to do. In the past, we've asked them to be pretty. Good, we can keep doing that, but they also have to support life. If we don't support life at home, it's going to disappear. They have to sequester carbon. Way too much carbon in the atmosphere. A third of it has come from chopping down the forests on the planet. Let's put the trees back. When we do that, we'll clean and manage our water, manage our watersheds. Everybody lives in a watershed. Nobody has the right to destroy it. But we don't think that way. Those plants will also pump carbon into the soil. The soil scientists are waking up. They're telling us now that the soils can sequester 7 times the amount of carbon that's in the atmosphere. All we have to do is get the carbon into the soil. What does that? Plants. And then, of course, we also have to support pollinators at home. Why do we need to support pollinators? You will tell me we need to support pollinators because they pollinate our crops. It's a very anthropocentric answer. They do. They pollinate a third of our crops, but they also pollinate 80% of all plants and 90% of all flowering plants. Forget our crops. If we lost our pollinators, we would lose 80 to 90% of the plants on the planet. Not an option. It's not an option. So we're not talking about good land stewardship here. We're talking about essential land stewardship. And I'm still amazed I didn't hear about this in the presidential debates. There's a family that lives in this house. If they're not producing all the ecosystem services with this landscape that they need, they're going to have to borrow them from someplace else. Now, in the past, we borrowed them from nature. Not enough nature anymore. They're not going to borrow them from their neighbor because he's not making any either. They're probably not going to borrow them from their township's open space, if it looks like my township's open space, which is a giant mowed lawn with a paved path around it and people walk in circles around it. We think if there's not a building on it, that's good land stewardship. That is not good land stewardship. This is a house down the street from me, acres and acres of lawn. He's very proud of it. These are all calorie pairs, by the way, but it's not doing anything, any of that list that I just talked about. We've measured the area of lawn where southeast Pennsylvania, northeast Maryland, Delaware, 92% lawn. 92% like that, not doing what we needed to do. Only 10% of the tree biomass that could be in our landscapes, and they're usually these short-lived ornamental trees from Asia that are going to fall over in the first ice storm and release all the carbon they just sequestered. So we need the big guys back in here. And this is my neighbor's house with his 32 calorie pairs. Every plant he's put on the 10 acres is a non-native plant. Why? Because, again, we think of plants as decorations, and he just wants to decorate his yard. And when he goes to the nursery, he finds plants from someplace else. So our plant choice has been focused on aesthetics. Maybe they could be screen anchors or focal points, but it's all been aesthetics without considering the ecological roles that these plants have to play at home. But we could do that. We could find pretty plants that have food web value, that are protecting our watershed, sequestering carbon, helping the pollinators, doing all the things we need them to do. So let's talk quickly about how to do that. What does a biodiversity-friendly suburb look like? This is the most important thing we need to do. We need to put enough plants back where we humans are, that we build biological corridors that connect the isolated habitat fragments that are out there. If they're connected, they're not isolated anymore. And if they're not isolated in them, the populations within them won't be tiny anymore, so when they fluctuate, they won't disappear anymore. This is the single most important thing that we can do to stop the steady drain of species from our ecosystems. Where are we going to pull these plants? I suggest we put them in the area that's in lawn. We have 45.6 million acres of lawn in the U.S. That's the size of New England in lawn right now. We're adding 500 square miles of lawn every year, and we're doing it because it's a status symbol. It's a status symbol of being rich and wealthy. Came from the days gone by before we had lawnmowers. Only rich people could have nice lawns. Now all of us poor slobs can do it, but we continue. In the 50s, if you didn't have a perfect lawn, you were a communist. I mean, we keep changing the story, and now if you don't have a perfect lawn, you're just not a good person, and your neighbor's going to hate you. But we can change our status symbols. I went to Montana a couple years ago, and I looked around. They didn't have big lawns. So I asked my host, "Where are your big lawns?" He said, it's we only get 9 inches of rain a year, but he said, lawn's not our status symbol. I said, yeah, what is your status symbol? And he thought about it, and he said, big belt buckles. I think that's the answer. Because if we double the size of our belt buckles and cut the size of our lawn in half, and then of course we want to build those corridors out of the plants that are going to support all this biodiversity. This is what we used to do in the past. We built our house, put in a foundation plant, a few trees here and there, then we were exhausted, no more landscaping, so everything by default became lawn. Let's turn that on its head. Let's build a house and figure out where we do want lawn. We're not going to get rid of turf grass, because it's a perfect plant to walk on without killing it. So we need to figure out where we're going to walk at home. I look at where my neighbors walk on their 10 acres, and it's mostly lawn. Nowhere. Never outside. But what if you want to get married in the front yard? You need some lawn there. If you want to walk to the backyard, a grass path, throw the frisbee, have a barbecue, whatever you're going to do with your yard, that's where the lawn goes. Then everything else by default becomes heavily planted. And this is the landscape design challenge of our times. How do we get all these plants into our landscapes without them looking wild and messy? But if we convince our neighbors to do the same thing, now we've got the connectivity with the woodlot over here and the woodlot over here. Not only have you stopped the drain of species from your neighborhood, you've reversed it. They will come. Our area that was mowed for hay when we moved in, I didn't count the breeding birds, but not many on a hay field. We now have 54 species of breeding birds at home. And it came pretty quickly. We've been there 16 years at this point, but they've been there for a while. We still have lawn, so we'll still get to play with our lawnmowers. It'll be okay. And if we do this in half the area that is in lawn right now, let's make the math simple, say it's 40 million acres, cut that in half. We can build a new national park. We're going to do it at home, so we'll call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains, add up all those parks, still less than 20 million acres. So let's do that. Let's take this nice grass strip here. That's the entrance to the Toledo Zoo with its nice dandelions. Let's turn it into that. And when they did this, the board of directors went crazy. They said, no one's going to come to the zoo anymore. Really. Let's take areas that look like this and put the plants back. They say you can't put a big tree in a small yard. Go down south where they love their live oaks. They do it all the time. We can do it. That's the new land ethic in agriculture out in the Midwest. This is Iowa. Think of all the effort goes into maintaining that. No more weeds, no more monarchs, no more bees. But it could be this, and that's also Iowa. They're starting to catch on, starting to fix it. Let's take these square things here. Tournament. Now, this is a landscape from Fisher's Island, high-end island where the Roosevelts live. I should have included more of the house, but this landscape is doing everything I've been talking about except supporting the pollinators, so let's put in a pollinator garden as well. Now, this is a mulch sculpture that proves you can't use native plants in a formal planting. But nobody told the folks in Indianapolis this is a formal garden, all native plants. That's the first year of the planting. And of course, that's an urban legend. Formality is a function of the design. It's not a function of the plants in that design. Our native plants are used in formal gardens in Europe all the time. And it's okay because they're non-natives over there. This is a corporate landscape that invites the employees to come out at noon to get sunburn. It could be a beautiful setting like this. And great research is showing if you spend just 15 minutes in a setting like this, there are measurable medical benefits. Your blood pressure goes down, your stress hormone, cortisol, goes down, your cancer is cured, you don't get divorced anymore. Why do I say that? The research is showing you get the same medical benefits that you get from intense meditation, and that's been shown to boost your immune system. It also restores your attention span. Our attention span is eroded. As soon as we wake up in the morning, it's eroded all day long, and by the time we come home, we're crabby, we yell at our spouse. 15 minutes in here, your attention span and you become a nice person again, is restored, and you won't yell at your spouse anymore. So I'm going to put another ball up here, call it mental health. We can call it physical health. Put a plant outside of a hospital room, and the patient gets better from it. Put a tree outside of a classroom, and test scores go up. Why? The connection seems to be with stress. When you reduce stress, you do everything better. How do you know when you've succeeded? When you have holes in your leaves. This is holistic gardening. This is a shingle oak leaf, and like my white oak, it has decided to pass on part of its energy to a caterpillar, which is now in the belly of a bird. If the tree was not willing to do that, we wouldn't have any life in your yard. So if you walk around, you look at your leaves, and there are no holes. Now it's early in the season. Now give it a little time. But if you have no holes in your plants, you have a dead landscape. You've got to do something about that. If your fireflies, your lightning bugs come back. I hear all the time, I don't see the lightning bugs I used to see when I was young. Well, you know, they're not bugs and they're not flies, they're beetles. As larvae, they live in leaf litter. They are predators in leaf litter. And of course, if you neaten up and you get rid of all your leaf litter, you've thrown out where the larvae live, what they eat. If you have Chemlon, you've poisoned them. If you have a security light on all night long, you've interrupted their communication when they're trying to get together. So if you get the fireflies to come back, you're doing several things right. And of course, if you have breeding birds at home, that's the best measure, because you can't have breeding birds at home, breeding on your property, unless you have the food to support them. So we could save nature, but only if we learn to live with it. And I'm going to leave you with one short story about how easy this can be. It turns out that the residential neighborhoods in South Florida accidentally saved this beautiful butterfly from extinction. That's the Mattila butterfly. It's beautiful as an adult, it's beautiful as a larva, it's beautiful as a chrysalis, but it's an extreme host plant specialist. Only eats one species of plant, the kunti, which is a native cycad in South Florida. Well, kunti has an interesting history. It had a lot of starch in its roots, and the Seminole Native Americans knew that. They used to use it as a source of starch when the settlers came to Florida. Seminoles taught them it had a lot of starch in kunti roots. Then around 1900, somebody had the bright idea of creating a starch industry out of kunti roots. In the census around 1900, 80% of the people in Miami filled out their occupation as being starch gatherers. And they were. They gathered all the starch, eliminated kunti from the wild, and it's still extirpated from the wild. But there were a few plants in gardens, and that's how it carried on. But if you take the host plant of this butterfly away, it of course disappears. 1973, we got the Endangered Species Act. There was a desperate attempt to find some Mattila so they could get it listed as an endangered species so they could get some federal funding to try to save it. But nobody could find any. So instead, they got it listed as officially extinct. But about that time, the horticultural trade recognized kunti as a valuable landscape plant. It does well in the sandy soils of South Florida. It's a low-growing evergreen shrub. So they started to promote it. And now it's common in parks. It's common in bigger neighborhoods. And look who showed up again. So I used to say nobody knows where it came from. Somebody claims they found a remnant population on one of the Keys, which is now out colonizing the mainland. But what I love about this story is it truly was an accident. They never got the butterfly listed as an endangered species, never got any conservation money, which is good because we don't have any conservation money. All they did was change the palette of plants that they use in residential landscaping by one. They added kunti, and the butterfly saved itself, which means this is a really powerful form of conservation. If we can save this butterfly by accident, by changing the way we landscape, think what we could do if we made conservation a conscious goal of landscaping. I think it's going to work. Nature's turned out to be a lot more malleable and resilient and forgiving than I ever thought she would be, but I can guarantee she's not endlessly forgiving. There is a point at which she will not bounce back. But I do think she will give us one more chance. And don't forget what the Donald says, make America native again. Thank you very much.
Wow, that was powerful, and a great choice for Judy and Raina and others for picking up that presentation. We've encouraged you to put your questions into the chat box. We've got some that were emailed in as well as already lining up. I welcome, and hopefully you should be seeing there on your screen, Professor Heather Mattila from Wellesley College. Thank you for joining us on your birthday this evening.
Thank you.
We all wish you a happy birthday.
Thank you. It's a great topic to share with people on your birthday. So inspirational.
That's a great gift for us. Thank you. And Raina McManus, Chair of the Wellesley Natural Resources Commission. So let me start with some questions. The first one is, I'll hand it to you, Heather. What effect is yard pesticide spraying to reduce mosquitoes and ticks having on insects that are targeted and other insects? Let me stop there. I'll let you answer that one first.
Yeah, that's a really complicated question because it depends what you're spraying with. But most of the time, these chemical sprays are generalist killers for insects and other kinds of arthropods that they have these biological systems that are different from vertebrates. So we feel safe spraying them because they don't hurt our pet. They apparently don't hurt our pets and people. The jury's out on that too, but they're known to have efficacy against these arthropods. And the problem is, it is very difficult to control one thing that's perceived as a pest insect or arthropod and not kill what we call the non-targets. So some people try and do this with really directed sprays, but when it comes to mosquitoes and ticks, these are just in the environment. The larvae are in the water, the adults are in the air, and the ticks are everywhere. So, you know, I just cringe. In the last couple of years, people have been spraying for ticks and mosquitoes, entire neighborhoods. And it is just, to me, a disaster. There's no really targeted way to just kill those things. And even if you just try and affect those things, like Doug says in his lecture, there are things we like that eat those things. And we need them to be healthy when they try and ingest these predators. We want them to be the natural control. So if we end up spraying for these things we think are bad, we're hurting everything else we think is good in the ecosystem. It's awful, if you ask me.
Thank you. There was a follow-up to that. Some of these sprays are billed as organic, so are they harmful?
Yeah, I'll say again, many of the things that we use to control insects come from plants. As Doug mentioned, plants have evolved all of these tricks to try and control the things that want to eat them. And some of them are really, really good at it. And so we as researchers and scientists over the decades have gone to them for the solutions for how to kill insects, how to get them away from us. And so a lot of these pesticides are either based on analogs of things that you find in plants or things that are directly derived from plants. And there's no way to say that something that is organic is not going to be harmful to other things in the environment, because it is intended by the plant to kill things that might eat it. And the problem is non-targets share many of the same bodily mechanisms. And so they would be susceptible if you're spraying it broadly, and it's not just in the single plant that it was designed to control by the plant, you are applying it to all of those invertebrates, those insects, the arthropods in your environment. And again, that goes up the food chain in some pretty dramatic ways. I could go on forever about that, but there is no easy way to feel comfortable with this idea of spraying something that's organic and thinking that it's entirely safe. That's not the case. The safest thing you can do is try and promote a habitat that allows the natural balance of things to try and control the insects that you don't like promote a habitat that does allow for predators to thrive, so that those predators, whether they're vertebrates or invertebrates, can try and keep your unfavorable insect populations in reasonable check without the expectation that there be none of them in the environment.
Right.
I'd just like to jump in and say that the term natural and organic is really unregulated and kind of thrown around a lot. So a lot of times you might think that what your landscaper is applying is natural, but the minute you see those little yellow flags go up, those are, poison, and stay off. So, it's best to just let nature do its thing.
If I could just quickly say that I love Doug's point that he has made several times in this talk about we have to come up with a new standard of what's acceptable in our visible landscape, that we should look at some herbivory as actually quite encouraging. And if we have things that are native and are getting eaten hard, we should give it time for the natural predators in the environment to swing into action and not just feel like we have to immediately take action ourselves with a chemical.
Great. Professor Mattila, question from Cindy. How does the State Board of Health respond to your observations about the dangers of aerial spraying for mosquitoes, which I understand has already started again this year in an effort to control for Triple E and West Nile virus?
Yeah, well, I mean, I can't say how they directly have responded to me. I share a concern that my general sense is as soon as human health is involved, it is very hard to, at the present time, with the current state of understanding of the public, to sway the public that it is more important to have an ecosystem that supports more bugs and birds and all the things that come along with a healthy ecosystem than to actually save human lives. I think the problem really lies in this lack of understanding of how we all are really interconnected. Most people don't understand those fundamental ideas that we need a healthy landscape in order to ultimately support humans. It's just not apparent to us as humans operating in a modern society unless you really dig into the topic. So frankly, when there's public fear about any kind of tick or mosquito-borne illness, it tends to, at this point, win out, which is why I think there just needs to be this real push for education at all levels. You know, people who own homes or corporations in charge of space, people educating children, that we need to really start getting this idea into their head. You know, the classic Silent Spring idea from the 1960s seems to have evaporated from the public consciousness a little bit, and we need to revisit those ideas that these things build up over time, and our more modern solutions still have some of the same problems, many of the same problems.
Thank you. Question from Anne. What about invasive Asiatic garden beetles? Do they not eat native plant species?
Well, not all garden beetles are predators. So let's just think about this question broadly. When you have invasives come into a new ecosystem, it is really hard at this point to make generalizations about how that's going to go. We don't know if they eat plants only. We don't know if they're omnivores and eat both plants and animals. They could be different they could have different habitats at totally different parts of their life stages. So we can never really predict what is going to happen. And a lot of these organisms that are damaging at the adult stage of their life are attacking only plants, and tend to be things that look for, you know, protein in other organisms to ingest at an earlier stage in their lifetime when they're growing. So overall, it's really hard to, on balance, to just give generalized advice about, you know, this specific species or that specific species. If you're thinking about Japanese beetles, they're known mostly for causing damage to plants, and a lot of that damage goes unchecked because they don't have natural predators in our environment. So overall, it's, you know, I'm a honeybee specialist, and I am very much aware that I study an animal that is very economically important, but also not native to North America. And it is here to pollinate plants that are also not native to North America that everyone wants to eat. So I feel like these are excellent questions that open big cans of worms over and over again. And many of them have enormous question marks on them about how exactly these invasives affect ecosystems, what they eat and what they'll eat here where they land.
Great. Let's go to the pests. Call them in. I've got rabbits. I've got chipmunks destroying flowers, planted phlox, and ate them all overnight, including the hosta. Any idea how to help phlox reflower? Keep rabbits away from plants. There were a number of folks who had similar questions to try to deter these animals.
Raina, you're hopefully a garden person and can weigh in on, you know, these specific garden questions. I would actually like to hear your answer too.
Well, I'm not sure if flux will come back, but I'm sure it will come back next year, if not rebloom this year. But to keep any of the little critters away, I would just say that chicken wire is your best friend, especially when the plants are new and establishing. And if you get the non-galvanized shiny chicken wire, it will blend really well into your landscape. So it won't look like you've got cages anywhere, but it's usually just until the plants get established that you have to worry about that. But yes, if you're going to plant new plants, please protect them with fencing.
Got a question here from Becky. I'm guessing under her window, she doesn't want to plant an oak tree. Are there any small growing native plants to put in that location? And I will refer to, I see here, we'll be printing out links that Cricket Blasts had a large number of native plants as replacement for invasives. We'll be sending out a link later too and show you where that is on our website. Raina, any other suggestions?
So of course you would want to know the site conditions. Are you getting sun? Are you getting shade? Are you in a moist location, or do you have dry soil? So all those things are important to consider. And there are just so many beautiful native shrubs. There's the honey locust. No, not the honey locust. Anyway, I won't go there. But if you go to the Native Plant Trust, and they have lists of many beautiful shrubs and plants that you can plant, and they sort them by the site specific locations that you would need for sun or shade or moist or dry.
Great. Let's see. We need to plant more NRC space. Paul Kramer. All right. Let me see if there's any other questions. Anyone have any final questions they want to put into the chat? And while they're doing that, I'll say Raina, you want to, from the NRC perspective, any concluding remarks?
So I just say that we're so lucky to have Cricket Blast in town. For many, many years now, she's been planting native species. She totally recognizes the value. When I first met Cricket, when I was first elected to the NRC, I visited her in her office and she had Doug Tallamy's book out. So I knew that we were in the right place. As Judy mentioned earlier, we are not using pesticides on our town-owned lands, and we do as much education as we can to the public about not using pesticides on their own properties as well. And we're just really excited for Pollinate Wellesley to create those corridors that Doug Tallamy was talking about. We have wildlife corridors in town, and now we are trying to create pollinator corridors to help our important insects as well.
Great, thank you. And Heather, any concluding remarks as well?
Yeah, I'd love to drive home a point. Maybe it was brought up in the earlier discussion, but when I watched Doug's lecture again, I watched it all the way to the end, and he brought up a point that I think is just really important. It's a hot topic amongst people who care about pollinators these days and who are doing research on pollinators, the idea of making sure when you buy plants that they haven't been pre-treated with systemic pesticides. So even if the grower themselves tells you that they haven't applied anything, these systemic pesticides can be incorporated into plant tissues from the seeds onward, and they're highly persistent. When they shed greenery into your yard, they shed greenery carrying these pesticides, and they last a long time in the environment and we're learning effects way beyond the invertebrates that are visiting those plants to pollinate them. They are affecting the birds that eat those, that visit the plants too, and eat the animals that have been at those plants as well. So I would encourage everyone to really grill your plant providers about whether or not they have been pesticide free their entire life before you purchase them.
Excellent. Thank you so much, Professor Mattila and Raina McManus, for joining us for the question and answer. Judy and B and Katie, thank you so much for helping to organize this first event and the preceding ones. As a reminder, next Thursday night and the following Thursday night, same time, same channel, same link. As you have this one, we will email out reminders either the day before or the morning of with the link, or put it into your calendar. It will be the same. And so now that we have a background on this and the reasons why, now we'll get further into so what do we do about it? So we've put many links into the chat box. If you've copied and pasted and opened those up in the meantime, we will be emailing out those links, and you can find them on the Wellesley Conservation Land Trust website as well under more resources and native plant and pollinators. So thank you all for coming tonight, and we will see you next Thursday.
Thanks, Michael, very much. That was great.
And have a great rest of your birthday.
Thank you. Thank you. I love that lecture. I'm going to use it on my final exam for my class this semester, make them watch it and come up with some experiments to prove his ideas. So it's so great.
Perfect.
Thank you.
Good night,
Bye.
everyone.
Good night, everyone.